Hello guys, I'm back. Today I will talk to you about what you must do if you need to run your process, your cooling water or your chiller water below 0 Celsius degree. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to get hundreds of contents related to chemical process engineering and plant design. There are some situations where your cooling water in a system can reach below 0 Celsius degree. And if that happens, you can solidify your water and that is not good for the process. So there are some ways to avoid this kind of situation that can happen because the weather, let's suppose that you are in a facility in Alaska or in Canada, or because you need to have a chilled water operating below Celsius degree to do the heat exchanging with your process. So to avoid this kind of situation and work and operate safely your process, you need to add some components to your water. And there are basically two main components that you can add to your chilling water. There are many other components, but here I will focus in two. The first one is ethylene glycol. When you add ethylene glycol to a solution of water, you decrease the freezing point of this water. And based on that, you are able to operate below 0 Celsius degree, like minus 10 Celsius degree, minus 20 Celsius degree, depending on the amount of ethylene glycol that you add to your fluid. Another component that can be used for this purpose is the propylene glycol. It's very similar component, but different than ethylene glycol, it is not toxic. So in food industry, in any process where you can have the contamination of the coolant with your process and it gets to the human use, for instance, you will prefer to use propylene glycol because it's not toxic in comparison with ethylene glycol. And as a chemical process engineer working with plant design, how is the procedure to determine the amount of ethylene glycol or propylene glycol that you must add to your solution? The first thing to observe is that when you are doing the composition of your fluid in a process simulation software, you have basically three main fractions that you can specify. You can specify the mole fraction, the volume fraction, or the mass fraction. And the amount of ethylene glycol or propylene glycol depends on the chart that you are using. If I am using a chart set by percentage of volume, the value, the absolute value that I will have for ethylene glycol will be different for the same desired temperature. It will be different if I use a chart with percentage in weight. So the first thing to observe is that what is the source of information that you are using? Percentage volume or percentage age? So here, just to give you an example, let's suppose that I want to guarantee a freezing point of 20 Fahrenheit for my fluid, my coolant fluid, or for my chilled water. If I use a percentage volume chart, I will go to the 20 Fahrenheit and look for 20% of volume of ethylene glycol to be mixed in the water. So in this case, I need 20 percentage of ethylene glycol. If I use the same 20 Fahrenheit as my freezing point for my fluid, but now I am using the chart in weight, I will have, instead of having 20% in volume as my reference, instead of having 20% as my absolute value, I will have here 10% in weight that will correspond to 20% in volume. But the main concern here is that the absolute value to be used when you are talking about weight is different from the absolute value that when we are talking about volume. So in this way, we have 20% in volume and 10% in weight. So you can see that there is a differences if you are defining your solution in percentage of volume and percentage of weight. So most attention to that to not lose the performance of your system. So what we define first? We define first the percentage of ethylene glycol to be added to the solution, or we define the temperature that we want to. To do with chemical process engineering in plant design, you must understand what are the requirements for your process. So in the first site, what I will observe is that what is the operating temperature that I need for my process. Let's suppose now that I will deal with minus 10 Celsius degree. So if my process must have a coolant with minus 10 Celsius degree, I can come from this chart by volume, percentage in volume. I can look here, minus 10 Celsius degree, and I will have around 25% in volume of ethylene glycol. But if I am operating at minus 10 Celsius degree, this is my normal operating point, and I can have deviations for this process. I don't know how much the chiller machine is able to achieve if I have low flow, for instance, or if I have a disturbance in my process. So as a chemical process engineer working with plant design, you must always think about the safety margin for the process. So instead of defining the volumetric flow, the volumetric percentage of my ethylene glycol as 25 Celsius degree, I will add, for instance, it will depend on the guidelines of your company or good sense. I will define the lowest freezing point as minus 20 Celsius degree, because I will have at least 10 Celsius of differences between the normal operating temperature and the lowest the lowest possible temperature. And with that, my effect, instead of having 25% of volume of ethylene glycol, in the end, I should guarantee around 35–37% in volume of ethylene glycol. If 10% is too much, I verify that my chiller machine is not able to reach minus 20 Celsius degree, but minus 15 Celsius degree. I can work on that and eventually remove or change the percentage of ethylene glycol that I needed. So instead of defining as minus 20 Celsius degree, I could define as minus 15, and based on that, I would use 30% in volume of ethylene glycol. And doing this way, you will guarantee the operation of your process, you will guarantee the performance of your process, and you will guarantee the safety of your process, that everything that you must look when you are doing with or when you are working with chemical process engineering in plant design. If you want to know how to set a fluid, how to set components on Eisenhower, take a look in the video that will appear to you right now. This is it. I hope you like it, and I'll see you soon in the next video. Bye bye.